Okay, hi guys, welcome back. Okay, so for this video, it'll be Pythagoras theorem, and I need you all to look at page 7 of your worksheet. Okay, so I'll just go through one simple question here on the application of Pythagoras theorem, which we'll be doing soon by measuring the length or the height of a school building. Okay, so let's look at try it 5. Simply saying, right, given this situation, okay, so take some time to read the question. You may want to pause the video, take about 30 seconds. Okay, after you finish reading the question, right, this question is as simple as just this. It's just about two triangles. Okay, so the first triangle I'll draw in blue, the second one I'll draw in red. Okay, and they share the same height. Now the only difference is this, and of course this. Sorry, let me draw it nicely. Okay, so these are the triangle that we are interested in, and given the dimension which is given in the question, they want us to find the distance AB, which is basically this distance. Okay, so you see you have the big triangle here, okay, and the smaller triangle. Okay, what we can do is that we can use Pythagoras theorem to find the length AF. Okay, so basically AF, okay, sorry, AF belongs to blue, so AF, okay, AF minus away BF equals to AB. Okay, so this is exactly the final step that you are looking at. Okay, and of course AF, right, is just using Pythagoras theorem. We're actually able to find AF. Okay, and that is given that AF square plus 48 square equals to 88 square. Okay, I'm sure you can find AF. So AF equals to, okay, and for how about BF? Okay, same thing. BF can be found using Pythagoras theorem, and that is BF square plus 48 square equals to 60 square. So what is BF? I'm sure you can do the math yourself too, and after that you can proceed on to find AB. Okay, so this is a simple application of Pythagoras theorem in a question like this. Okay, other question would be something like here, question 3 here. Okay, so they want you to find the distance CD. Okay, if you can draw a triangle here, you realize CD is actually the hypotenuse, right? And of course this is 2. Okay, if this is 1.5 and this is 2.5, that means this part here is 1. Okay, and it's as simple as that. So CD square equals to 1 square plus 2 square. That is CD square equals to 5, and CD equals to square root of 5 cm. Oh, sorry, meter. Okay, so I think it's quite simple. The harder part will be when I mix in simultaneous equation, which I'll go through in class tomorrow. Okay, let's continue on. Okay, I will want to finish up one of the consolidation exercise. So sorry, hold on. Okay, so for consolidation exercise 1, consolidated exercise 1. Okay, page 12, 13 and 14, the answers are given. So please take note of the answers, and if you have any queries, please let me know. For this video, I'll go through consolidated exercise 2 plus one question, which is question 5 from consolidated exercise 1. Okay, now the reason why I want to go through question 1 is because I think some of you have forgotten how to form your quadratic equation. Okay, so in this part we'll look at that. First, please identify that we have this as our A, B and C, and C is obviously the hypotenuse, right? Okay, so with this, you know that the only equation that you can form therefore is by using Pythagoras theorem. Okay, so you see a right angle triangle, they ask you to form an equation for part A. The only equation that you really can form is by using Pythagoras theorem, and there you have it, 2x plus 1 the whole thing square plus 8x the whole thing square equals to 9x minus 2 the whole thing square. Now please remember that a plus b the whole thing square is not equals to a square plus b square. Okay, this is something that when doing algebra you guys are very prone to this kind of mistake. Okay, so please take note, this is wrong. Okay, this is wrong. Now so what we're going to do is the old umbrella method. Okay, plus 64x squared equals to 9x minus 2. 9x minus 2. Now remember that 8x the whole thing square is the same as 8 square x square. Okay, which is 64x squared. Now using the umbrella method, what we'll get is 4x squared plus 4x plus 1 plus 64x squared equals to 81x squared minus 36x, right, plus 4. Okay, mix them all up together. So bring everything to the left hand side. Okay, bring all to left hand side. Okay, after bringing everything to left hand side, what you should get is 13x squared. Okay, so 4 plus 64 minus 36. Okay, do I have a I might have a careless mistake somewhere. Oh, okay, yeah. Minus 13x squared plus 40x. Okay, then minus 3 equals to 0. Yeah, I want to make it look nicer because the question asked for this, right? So we can just change all the sign. And remember the bracket shown. Okay, so we have shown whatever they were asking for. So the question is asking for us to show this equation, and we have shown. Okay, so remember bracket shown, and this came by using only Pythagoras theorem. Okay, part B asks you to solve 13x squared minus 40x plus 3. I think it's quite straightforward. What you should do, you see a quadratic equation here. Okay, we have a quadratic equation. We have 3 terms. What do we do? Okay, obviously we're going to do this, right? 13x squared. So we have 13x and x. Okay, and we have 3 here. So and this is minus 40x. So we have 3 here and 1 here. Okay, but remember this is minus, so probably this is minus also. So I have this, and then I have minus 39x here and minus x here, which is minus 40x. So this is correct. Now remember how to read this. Okay, we're going to read it horizontally. Okay, so we have 2 answers. So 13x minus 1 and x minus 3 equals 0. So therefore x equals to, sorry, I'll just do the full working. Okay, 13x minus 1 equals to 0, or x minus 3 equals 0. So we have x equals to 1 over 13, or x equals to 3. Now so that's it for part B. Okay, we have solved. Solve means finding the value of x, and we have found the value of x. Now part C, they ask you explain why one of the solution is not applicable. Okay, so the solution, remember the triangle. So the triangle is 9x minus 2, 8x and 2x plus 1, right? So let's see the hypotenuse, right, is given by 9x minus 2. Why did I choose a hypotenuse? Because there's a minus sign, and we want to see if it's valid. Okay, if we substitute in whatever value of x. So if x equals to 1 over 13, then 9x minus 2 equals to 9 times 1 over 13 minus 2, which is 9 over 13 minus 2. And you actually get a negative number. You get negative 1, 4 over 13. So this is negative. Okay, now if x equals 3, then 9x minus 2 equals to 9 times 3 minus 2, you get 27 minus 2, you get 25. So this is positive. Now, is there such a thing as negative length? No, right? So we have to reject. So the reason is that the answer for C is this. Okay, x equals to 1 over 13 is rejected since hypotenuse will be negative if x equals to 1 over 13. Okay, so this is your answer for question 5. Okay, clear? So that's it for question 5, and I'll leave the question 1 to 4 to you guys. Okay, now we'll go through consolidated exercise 2, but I won't go through everything as well. There are some repeated questions, so I'll just look at question 3, 4, and 5. Okay, so over here, take some time to read the question as well. Right? And you want to find the value of x, the value of y, and the area of triangle ABC. So A, B, C, basically the area of the big triangle. So remember, the area of triangle is half times base times height, and in this case half times 12 plus y times height. Okay, I'm not going to do the question out for you because the answer is already here. Okay, so what you're going to do, you're going to try it yourself, but I'm teaching you how to do it. Okay, so to find x, look at this triangle, and I think it's quite obvious that we can use Pythagoras theorem, and x is the hypotenuse in this case. Okay, to find y, then there is a big triangle here, right? And I think it's quite obvious that we can also use Pythagoras theorem for the blue one. Okay, but please take note that for the blue one, if this is A and this is C, then B equals to 12 plus y. Okay, or you can just simply do this, I'll just do for the blue one. So using Pythagoras theorem, right, we have 5 square plus b square equals 21 square. From here we can actually find b square equals to 21 square minus 5 square, so b equals to something. So remember that 12 plus y will then equals to b. Okay, and you can actually solve for y. It will be simpler because you don't need to use the umbrella method. Okay, if you're going to sub it in from the start, you will realize that we have this, and then you might want to expand this, which will make everything very messy. Okay, which might give rise to careless mistake. Okay, so my advice is to use this first. Okay, I recommend this, but I won't say that this is also correct. Okay, so I think question 3 is fairly simple. Okay, let's move on to 4 and 5. Now question 4, trapezium. Now if you have forgotten, the only thing I'm concerned about is that you have forgotten the area of trapezium. Okay, so given a trapezium, I have two parallel sides, we call it A and B, and the height is called H. So in this case, the H is half times A plus B. A plus B will be x plus 21, and then the height will be 12. Okay, so this is the formula. Okay, so to find x, I think it's quite simple as well. We can just use Pythagoras theorem. Okay, if you use Pythagoras theorem, you are going to draw a triangle here. This is 12. Find this, you can actually find this part is actually x. So if we call this y, then x equals to 21 minus y. Alright, and for the last question, okay, they are going to find the value of x. They share the same height here, you see. So we have two triangles again. This is the first, and this is the second. Okay, so I'll actually circle x in red. Okay, now using Pythagoras theorem, we can actually find the height. Let's call this h. Okay, so h square plus 8 square equals to 15 square. So we find h, right? If we are able to find h, okay, then we can go on to this, and we say that h square plus x square equals to 30 square. So x equals to, yeah, okay, and then that's it. The answer is here, so please double check. Okay, please self mark, and then you can pass your homework to me. Okay, and then we will actually end chapter 7 in this manner, and the next video will be talking about chapter 8. Okay, so do pause the video whenever you want to, and I think I'll end the video here. Okay, thanks. Okay, hi guys, welcome back. Okay, so for this video it'll be on chapter 8 on trigonometry, and I'll go through all the way until page 9. Okay, so first thing first, let's turn to page 3 and let's finish up triad 6. Alright, okay, now take 30 seconds to read triad 6. Then we will identify the opposite, the adjacent, and the hypotenuse for the first triangle, and this is the first triangle that we are concerned about. Okay, I'm going to erase it, I'm just highlighting for your purpose. Okay, so this is obviously the hypotenuse. Remember, the opposite is always the one opposite the angle, so this is the opposite, and we have this as our adjacent. Okay, so what do you want to find? You want to find the width BC of the shaft. Okay, now you should realize that this point to this point is the same as this point to this point. So basically BC, right, is the adjacent, sorry. Okay, so we have the hypotenuse and we want to find the adjacent. We have the angle. What thing uses A and H? Okay, so it should come to you that cosine theta equals to adjacent over hypotenuse, and therefore cosine 23 degree equals to adjacent over hypotenuse, which is 3. Okay, so adjacent equals to 3 times cosine 23 degree. Press your calculator, you should be able to get answer. Okay, give me a minute, I need my calculator. Okay, and the answer will be 3 times cosine 23. You get 2.7615, which taken to be 3SF is 2.76. Okay, so that's our AC, and this is in meters. Okay, so this is our part A. Part B, they want to find the wall AB. So this is AB, right? Okay, you already have CD, so AB is nothing but CD, which is 2 plus AE, which is 2 plus AE lah. Okay, so in this case you want to find AE. I'm going to use the black pen. Okay, AE is the opposite. Okay, I have the hypotenuse and I have the angle. Okay, so opposite and hypotenuse, I hope it comes to you as Picasso, right? So sine theta equals to opposite over hypotenuse. We have actually O over 3. Now, some of you might say, hey, but in part A, I already found an adjacent. So can I put a tick to this? The answer is yes. But what if your adjacent answer is wrong? And if you are going to use a wrong answer to find another answer, that another answer will be wrong, and therefore both your answer will be wrong. So don't do that. Okay, it is safer to use the hypotenuse in this case. Okay, so sine theta is sine 23 degree equals to opposite over 3. Okay, so the opposite will then be 3 sine 23 degree, which is equals to 3 sine 23. You get 1.7219, which when round off to 3SF is 1.72. So AB is just 1.72 plus 2, okay, which is actually 3.72 meters. Okay, and that's it for page 3. Okay, now let's move. You might want to pause the video at this point if you need some time to digest. Okay, so here it is. Okay, otherwise please move on to page 6, 7, 8 and 9. Okay, I won't go through everything likewise, but let me just go through quickly question 7C. Okay, now 7D, right, you just need to be very careful. Okay, if you cannot see this, right, just redraw the triangle first. So we have one triangle here, then we have another one over here. Okay, redraw them separately, it's fine. Okay, so if I were you, I'll redraw the triangle here. This is the right angle, remember, X, Y and 45 degree. Now redraw the red one. Okay, then the red one is X here, 20 here, and this is 55 degree. Okay, and this is the right angle. Okay, so redraw the triangle, life will be much simpler. Okay, over here is less messy, so let's just take this as a quick practice. Okay, I want to find y, I want to find x, right? So if you look at this first triangle, right, I have y, I have x, and I don't have the hypotenuse. I cannot find anything. So let's not look at that triangle ABD. Let's look at the second triangle, the one below. Okay, so I have this and I have this, but what are they? Now, if 50 degrees here, then this is the opposite. So this is the adjacent and the hypotenuse. So I have the adjacent and the hypotenuse. Please note that it is car, which is cosine. Cosine theta equals to adjacent over hypotenuse. Then we have cosine 50 degree equals to the adjacent, which is 9 over the hypotenuse. So x equals to 9 over cosine 50 degree. Okay, use your cross multiplication for this. Know that this, right, cosine 50 degree is the same as cosine 50 degree over 1. Okay, so press your calculator. You get x equals to 14.0015. Okay, 3SF 14.0 unit, because there's no unit, there's no meter or cm, so we just write unit. Okay, now to find y, now that we have found x already, x is 14. Okay, now for the triangle that has y, right, this is 14, this is y, and this is 65. That means 14 is the opposite and y is the adjacent. Basically, then this will be tangent 65 degree equals to opposite over adjacent. Okay, I'm sure you can find then tangent 65 degree equals to 14 over y. Y will then be 14 divided by tangent 65. Okay, so press your calculator again. You get 6.528. Remember, it's 3SF, so you round off to 3SF, you get 6.53 units. Sorry, I forgot the S here. Okay, and that's it for page 6. Okay, I'll go through 7D in class tomorrow. I think 7A and B are pretty straightforward. I'll just give you all the answer in class tomorrow as well. Okay, now we come to question page 7, 8, and 9. Okay, same thing, I won't go through everything. I'll just go through question 2, because the answer are already here. Okay, so if you are wrong, you either come find me or you look at it again. Okay, this is pretty simple, so I won't go through. Question 3 is slightly challenging, and question 2 as well. Okay, so let's tackle these 3 questions, and then we can call this video a day. Okay, now find the distance from the bottom of the wall to the foot of the ladder. Take 30 seconds to read this question to understand what's happening. Okay, they want from the bottom of the wall to the foot of the ladder. So this is the foot. This is the foot of the ladder. Okay, foot of the ladder means the bottom of the ladder. Okay, so they want the bottom of the wall to the foot of the ladder. So basically you want this, let's call this x. So they want x, you have 8.4, you have 73 degree. I think it should be very clear already. Okay, 73 degree is here, then the opposite is here, then this is the adjacent, then this is the hypotenuse. So you have a and h, you use cosine 73 equals to the adjacent over the hypotenuse. Okay, which is your x over 8.4. Okay, I think you can do the rest. So x equals to something meters. Please remember this, meters. Okay, it's very important. And I think the answer is here, is 2.46. Okay, now question 2 here. A ladder is placed to lean against a vertical wall angle. Okay, so it's about the same thing. Yeah, you just need to identify what they are trying to find. So find the height of the ladder. So this blue color thing, right, is the ladder, right? So I want to find the height of the ladder. Basically, I want to find this. We call this y, and we realize that y is actually the hypotenuse. If this is the angle, then this is the opposite, this is the adjacent. So again, it's adjacent and hypotenuse and angle. Okay, so cosine 55 degree equals to adjacent over hypotenuse. Find h. and this is actually the height of ladder. Okay, I think it's quite simple. And let's do the last question and then we are done. Okay, now a rope is tied to a tree to prevent it from falling. Okay, the angle between the rope and the ground. Okay, so this is the ground, this is the rope. Okay, and this is the height at which it's tied to the tree. So we call this what we want to find out, height at which the rope is secured to the tree. Let's call this y. Okay, and let's call this y. So we have y, we have 4.2, we have 2 degree. But what is y? So we need to identify if the angle is here, this is the opposite, this is the adjacent, this is the hypotenuse. So we have the opposite and the hypotenuse. So this is a sine 52 degree equals to opposite over hypotenuse, which is our y over 4.2. Okay, so y will then be 4.2 sine 52 degree, which when you press your calculator, it should be rounded to 3SF. You'll get 3.31 meter. Okay, and that's that. Okay, now the last question, just a quick one. Area of triangle ABY, it will be this. Okay, so just draw a line, okay, here, and you'll get the area of triangle ABY. Then remember how to find the area of such a triangle. So if I have a triangle like this, the area of this triangle is half times base times height. But where's the base and where's the height? Now this is the height that we are looking at, and this is the base that we are looking at. Okay, so with this I will end the video here. Hope y'all can understand, and then tomorrow on we'll move on to page 10. Okay, so I'll see y'all in class again.